So as we progress along with these examples, it's important to keep in mind that, especially as we progress along within this chapter, that we read these problems carefully so that we're clear on exactly what is being asked, what the scenario is presenting. Now, the math will work, but we have to make sure that we're applying it correctly. And one way to do that is make sure that we take our time as we read a lot of these word problems. So for this first example here, the House of Representatives, it says there are 435 members of the U.S. House of Representatives. As of 2021, there are approximately 124 standing committees and subcommittees. A congressperson can chair only one committee or subcommittee. 3 of the House committees, Judiciary Committee, Ways and Means Committee, and the Foreign Affairs Committee, have chair positions available. How many different ways can these positions be filled? So a few things to point out. We have 435 members of the House of Representatives. There are 124 committees or subcommittees, and any congressperson can only chair only one of those committees. And then there are 3 yet to be filled. So of the 435 members of the House, 121 of them are already chair some sort of committee. So that gives us 314 members to choose from to fill these remaining 3 committees. So that can be written as 314 permutate 3. Here's our factorial, 314, and we're going to stop counting down after 3 positions. That can be written as 314 factorial. That's 314 minus 3 factorial. That's our 314 minus 3. That's 314 factorial over 311 factorial. The 311 factorial in the denominator will cancel out the 311 in the numerator, and of course leaving that with 314 times 313 times 312. And of course we start out with 314 and count down 3 times. 1, 2, 3. That comes out to be 30,663,984 different ways to fill these positions. For the next example, it says there are 33 cars in the starting field for the Indianapolis 500 motor race. If all the cars finished the race, how many different ways can the cars finish in first, second, and third place? Well, that would be 33 permutate 3. If we went ahead and followed the formula, we would have 33 factorial over 33 minus 3 factorial. That's then 33 factorial over 30 factorial. 30 factorial in the denominator will factor out 30 factorial in the numerator, leaving us with 33 times 32 times 31. And hopefully you're getting the gist of how these permutations work in relationship to the fundamental counting principle. So that comes out to be 32,736 different ways.